All right, we are going to talk about solving by factoring a little bit more. This time, we're not going to have just one x squared. We'll have a number in front of our x squared term. So our essential question, how does factoring help to solve and graph quadratic equations? And one other thing to quickly review, we're going to talk about the greatest common factor, and that's the largest factor that all terms in an expression share. So the process is a little bit different when we have a number in front of x. Now we can't just factor the back term, look for it to add the middle term. We have to multiply what's in front of the x squared, what's at the end. And now we're going to factor the number 24. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then this concludes our list. The back number is positive, so that means we had a positive 24. We're subtracting the middle term, so that means both of our numbers are going to be negative. So we want to look for the pair that adds to make negative 10, which for us is negative 4 and negative 6. And then instead of just writing x minus 4, x minus 6, now we have to draw the box. Three x squared goes in the upper left, 8 goes in the lower right. And it doesn't matter which one you write where, but negative 4x needs to go in one box, and then negative 6x needs to go in the other of the two that are remaining. So we're talking about a greatest common factor because you're always going to look across a row or a column to see what the greatest common factor is. What do both terms share? And between 3x squared and x, or 4x, they share an x. So we can factor out an x. Then look across the second row. Between negative 6x and 8, the x is negative, so we're going to need to factor out a negative sign. And then between 6x and 8, 6 and 8 are both even numbers, so we can factor out a 2. Then let's look up the first column. We have 3x squared and negative 6x. Both 3 and 6 have a factor of 3, or you could divide them both by 3. And then they both share, between x squared and x, they both have an x. And then lastly, because the x term when we're going up that second column is negative, we need to factor out a negative sign. And then between 4x and 8, the greatest common factor that they share is 4. So for now, we're just factoring. We would write our solution as 3x minus 4 times x minus 2. And there's our answer. We'll get more into the solving piece as we go on. Let's try one more like this. Again, we have something in front of x squared, so we need to take the a and the c. You can identify your constants first. Multiply the a and the c term. We should be getting negative 90. I'm going to write out the entire factor pair list. I did that just for the sake of time. But because we're adding the middle term of x, we need to give the bigger number the positive sign, or the bigger number will be positive. And we want to look for the pair that will add to make positive 1, which for us is negative 9 and 10. So here we draw the box. Six x squared in the upper left, negative 15 in the lower right. And of the two that remain, you put negative 9x in one of them and 10x in the other. Then look for the greatest common factors. between 6x squared and negative 9x, they both have a 3 and an x. And then here, 10x minus 15, they share a 5. And that time, because the x was positive, we factored out only a positive 5. And then you can go up the first column between 6x squared and 10x. They share a 2x. And then between negative 9x and negative 15, all they share is negative 3. So then you would write your answer, 2x minus 3, and then 3x plus 5. So these are nice examples because it's easy to see the A and the C. We have the middle term. Those are nice to work with. Sometimes we have to work with special patterns though. Like what, for example, happens if we don't have an x term. We talked about last section how if you don't have an x term, you probably, or you want to check and see if you have what's called the difference of squares pattern. And that means that your first term and your last term are both perfect squares, and then we're able to factor it using the special shortcut. So for us, 81x squared is a perfect square, 25 is a perfect square, so we're able to use the difference of squares pattern. And that's where if we have ax squared minus b squared, we can rewrite our product as ax plus b times ax minus b. So we need to figure out the square root of 81. We need to figure out the square root of 25. And then we're going to write our product as 9x plus 5, and then 9x minus 5. We may also see this special pattern where it'll work if you multiply 49 times 64, factor out that number until you find a pair that adds up to 112. You are going to get a huge list and you're going to find really big numbers if you try that way though. So you also want to check and see, can you just do the square property? Can you just use your binomial squared? So you need to check, again, the shortcut there, or the trick to look for. So ax squared plus 2ab plus b squared. And for this one, I'm just showing plus because we're adding the middle term. So we need to check and see, 49, is that a perfect square? 64, is that a perfect square? The answer to both those questions is yes. Square root of 49 is 7. Square root of 64 is 8. So now let's check and see if we do 2 times a, or 7, times b, or 64, do we get 112? And for us, yes. 2 times 7 is 14. 14 times 8 is 112. So we have our special pattern. Now we just need to factor it. And that's just going to be 7z plus 8 squared. And then we're done. You could also be subtracting the middle term, and now instead of a plus sign, when we factor, it's just going to be a minus sign. So let's check and see, is 9 a perfect square? It is. Is 121 a perfect square? Yep, it is. And then if we take 2 times 3 times 11. Does it multiply to make the middle term? And the answer is yes. 2 times 3 is 6. 6 times 11 is 66. So here is where we have the ax squared. This time it's minus 2ab. Sorry, I forgot an x on the last one. There should be an x there too. And then plus b squared. And that's exactly what we have. So the trick here, this time instead of a plus sign in the middle, it'll be a minus sign. So we're going to have 3x minus 11 squared. There's one other special situation where you want to look, or I should say there's one other thing you want to look for when you're factoring, and that's to see if you have out any greatest common monomial factors between your terms. So for this example here, we have 3x squared minus 300, and at first glance, I'm seeing, okay, well that could be a difference of squares pattern because I don't see the x term. But 3 is not a perfect square. 300 is not a perfect square. The thing that they do have in common is that they both have a factor of 3. So I can divide this entire thing by 3, and then I have 3 times x squared minus 100. And now it's x squared, that's perfect square. It's 100, that's perfect square. So I could rewrite this as the difference of squares pattern. And that's 3 times x plus 10 and x minus 10. We have another example here where that's where we want to look at first. If your leading coefficient is negative, you always want to factor the negative sign out. So for this question, a second way to look at this, you can do the box method backwards. Draw your two terms in the box, and then write what you're factoring out in front of it. So between negative 7 and negative 63, they share negative 7. And then between t squared and t, they share a t. So now we just need to look at what's left over if we factor that out. So if we had factored negative 7t out of negative 7t squared, all that's left over is a t. And we factored out negative 7t from negative 63t. Negative 63 divided by negative 7 is 9, and then your t's cancel. So this product would be negative 7t times t plus 9. And we'll look at just one more example. We have negative 5y squared plus 60y minus 35. All of these numbers end in a 5 or 0, so we could factor a 5 out of here. And then we're left, and sorry, I should say negative 5 with 5y squared minus 12y plus 7. Okay, I don't see any special patterns we could use, so we're going to have to multiply the a times the c and factor out the number 35. Because our middle term is negative, we want the negative values. And then we're going to use the pair negative 5 and negative 7 because that's what adds up to equal negative 12. I filled it all in because I'm running out of time, but when you go across the first row, you factor out 5y. Across the second row is negative 7. Down the first column is y, and then negative 5y and 7 for that second column, they don't share anything, so you can just say 1. Final answer is negative 5 times 5y minus